Hello, this is Tyler Beamer, math instructor at Haywood Community College. This is an instructional math video for DMA 050. The purpose of this video is to show students how to graph linear equations with a table of ordered pairs. So I'm going to do some examples here that are similar to the types of problems in your homework so that you can use them as a reference. So in this first problem, we have our linear equation here, x minus y equals 4, and the problem actually gives us a partially completed table of ordered pairs. So we have some x coordinates, we have some y coordinates, and we need to essentially complete these ordered pairs so that we can then graph those ordered pairs on our xy coordinate plane. And then graph the line, which is the graph of this linear equation. Okay, so we learned how to complete this table in section 3. So essentially we go row by row, and each row represents an ordered pair. So let's do the first row. We're given the x coordinate of 0, so I'm going to substitute 0 in for x. And I'm solving for the missing y coordinate. So I'm going to solve for y. So once again, 0 doesn't add or take away any value. So I have negative y equals 4. And then remember, there's a negative 1 that's in front of the y here. So I want to divide both sides by negative 1. So y equals negative 4. So that's the missing y coordinate for the first ordered pair. Okay. Let's take a look at the second row. In this case, I'm given a y coordinate of 2. So I want to plug that value of 2 in for y into my equation and solve for x. So add 2 to both sides. X equals 6. So we know that the point 6, 2 is going to lie on our graph. And then let's do the third row for the third ordered pair. So I'm going to slide this down here. So we have negative 1. So that's going in for the x. We're missing the y, so that's what I'm going to solve for. So I'm going to add 1 to both sides. And remember, there's a negative 1 in front of the y. So I'm going to divide both sides by negative 1. So that gives me y equals negative 5. So that completes the ordered pair. So what that tells me is that all three of these points, all three of these ordered pairs, lie on the graph of this linear equation. And of course, when we graph linear equations, they're going to form lines. So let me shift my graph paper over here. Okay, so let me label this graph. Zoom in so you guys can see a little better. Okay, I'm going to label this the graph of x minus y equals 4. And I essentially want to plot those 3 points. So 0, negative 4, so 0 on the x, negative 4 on the y, so that's a point there. 6, 2, so 6 comma 2, so 6 on the x, 2 on the y, and negative 1, negative 5, and those 3 points should line up to form a line. If those 3 points for some reason do not form a straight line, then we've got some issues going on, and you would want to find the mistake that was made in calculations and finding those ordered pairs. So I technically only need technically only need 2 points to form a line. So technically, after I found those 2 points, I could have stopped. But having 3 points is nice. The third point is kind of like a test point. If for some reason I happen to make a mistake in getting these 2 points and they just so happen to lie close together to form some kind of line, that line could still be incorrect. These 2 points, if I move this point anywhere on this graph and this one stays fixed, I can make an infinite number of lines. But I want to make sure that I make the line for this equation, right? So the third point verifies that essentially. All 3 line up to form a line, and that's going to be the graph of this equation. Okay. All right. So let's look at another example. That's a little bit more difficult. All right. So let me zoom out. So in this particular problem, we're given the linear equation and we're not given any points on the table. So basically the table's blank. So I need to complete the entire table of ordered pairs from scratch. And once again, we're going to find at least 3 ordered pairs. Remember, the third point is a test point, so I want to be certain that I have the correct line. So I can really start from anywhere here. I can choose values of x or values of y, plug those into my linear equation to find the ordered pairs that are on the graph of this linear equation. However, you want to do this so that it is easy to solve, right? So looking at this equation, I've got a negative for x here. So if I put positive values in here for x, this is going to remain negative, and then I will just have to essentially add the value of that to the inverse to solve for y. And that seems to be a pretty easy way to solve. You don't want to make these problems any more difficult than they need to be. So I'm also going to pick values that are pretty easy to work with. I'm just going to actually go with 1, 2, and 3. I kind of picked those arbitrarily, but I picked those because they're small numbers, so they're easy to work with, and they're whole numbers. That way I don't have to deal with fractions. And of course they're positive, so that when I plug these values into my equation and solve for y, which would give me the corresponding y coordinate that matches for this ordered pair, all I have to do is essentially solve the equation. So since that's a -1, I would just add 1 to both sides, and y equals 7. So I know that 1, 7 should lie on the graph of that linear equation. Okay. And I'm keeping these ordered pairs pretty small. 1, 7, that should easily be able to be graphed on a 10 by 10 XY coordinate plane. I certainly don't want to have ordered pairs like 22, 37, because then I would have to have a really, really large XY coordinate plane in order to graph those, even though it may be on the line. So let's look at the other one. If I plug 2 in for x, Right, I get negative 2 plus y equals 6. So solve for y, add 2 to both sides. So I get 2 comma 8. Plug 3 in for x, solve for y. So add 3 to both sides. Y equals 9, so 3 comma 9 is going to be a 3 comma 9 is going to be a ordered pair that's going to be on the graph of this equation. So those, like I said, those x coordinates I picked arbitrarily, but I tried to be wise in picking them so that the problem is easy to solve. Okay, I don't want to deal with any signs if I can avoid it. Definitely don't want any fractions, and I want to keep my numbers small so that it's easy for me to graph. Okay, so if we graph this one, okay, so this will be the graph of negative x plus y equals 6. So the 3 points that we had were 1, 7. So 1 on the x, 7 on the y, 2, 8. And of course my graph paper here is only going to 8. So I'm going to make another notch up here, which will be 9, 3, 9. Your graph paper that you will use on MyMathLab will be a 10 by 10 graph paper, so that'll be actually easily will fit on there. So once again, these 3 points line up in a line, which is what I want. Since we're graphing linear equations, the graph should be a line, and then of course connect the dots, and we get the graph of that linear equation. Okay, let's take a look at another example here. Alright, so this one seems a little bit more complicated. 3x minus 2y equals 12. So I have coefficients in front of these variables, which makes this more difficult. However, right, I still don't have a table, pre-made for me, so I'm going, from scratch here. I want to use 3 points once again. I want to try to pick points that are, going to work out easily in terms of me being able to solve this equation. So when I see a setup like this where I have the x and the y both on one side of the equation, I immediately start thinking about plugging in 0, right? So for example, if I plug in 0 for x, right, will that be easy for me to solve for y in my linear equation? So let's see what happens here. So if I plug 0 in for x, what happens is 3 times 0 is 0. That essentially goes away, right? 0 doesn't add or take away any value. So I get minus 2y equals 12. And as long as this coefficient of y will divide into this number here, then I'm good, right? Then I can solve for y here rather easily, and I don't have any fractions, and I don't have any numbers that are hard to graph, right? So this is the case, right? 2 is definitely going to divide into 12, so or negative 2. So if I divide both sides by negative 2, y equals negative 6. That's an ordered pair that's easy for me to graph. Okay, I don't have fractions. My numbers are still pretty small, so it's rather nice. Okay, so let's try it with 0 going into y. Right, so in this case, I'm going to leave the x as is, and I'm going to put 0 in for y. And then I'm going to solve this equation, right? Notice here that, once again, 2 times 0 is 0, so I get 3x minus 0, and 0 doesn't really add or take away anything. So this is going to basically become 3x equals 12, and once again, as long as this coefficient will divide evenly into this number on the other side, I'm good, and that's the case here. So that works out really nice. So divide both sides by 3, so x equals 4. So once again, that gives me a really, really nice ordered pair that I can graph. Okay. All right. So now at this point, we want to come up with a third value, right? So that we can get a test point here, and I can't use the 0 anymore, right? So let's try to be smart in how we pick this number. We want to make sure that whatever number we plug in for x or for y here, that when I add or subtract it and divide, I end up getting a integer, right? So a positive whole number or a negative whole number, and I don't have any kind of fractions on there, right? So let's think about what I could do here to make that happen. I know that this is a 2, so as long as the number on the other side is even, I can certainly divide that, right? So I'm thinking that if I plug in, say, a 2 in for x, then I can make this work. All right, so let's see how that works out. And some of this may be trial and error. You might pick a number, and then you solve, and you may get a fraction or a really big number that doesn't fit on the graph, and you want to just rework it so that you find a number that is easy to solve for and will fit on the graph. So a bit of this may be trial and error, but you should start to have this mindset, right, and see patterns in these equations, so as you pick numbers that work out nicely for you. So let's see what happens here if I plug a 2 in for x. Okay, so if I plug a 2 in for x and I solve for y, all right, well, I know that 3 times 2 is 6. And I know that to solve for y, I'm going to have to subtract 6 from both sides. And as long as negative 2 will divide into 6, this number on the other side here, I'm good, right? And so that's the case, right? I knew that obviously 2 is going to divide into any even number, so as long as this was even over here, I'll be okay. And that's the case. So minus 2 divided by negative 2, sorry, and we get negative 3. So we know that the point 2, negative 3 is going to be on the graph of this equation. Okay. So these are a little challenging, right? It's very open-ended. It allows you to kind of pick your own numbers, and sometimes that scares people. You know, people want to they get in this rut of just, you know, plugging in the numbers that they're given, and so this involves a lot more critical thinking. So let's graph this and let's see what it looks like. So alright, so let's zoom in down here. Adjust this so that you guys can see a little better. Alright, so this is the equation of 3x minus 2y equals 12. Okay, let me focus this. Okay, so the 3 points we had was 0, negative 6. So that's this point here. 4, 0, which is this point here, and 2, negative 3, which is this point here. And of course, as you can see, all three of those points line up. That's what we want. And connect the dots. La 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 la. We have our line, which is the graph of our linear equation. Okay. Alright, let me get another example here. Let me adjust this again. Okay, so we've got y equals 1/4 x plus 3. So we do have a fraction here. Okay, and as you notice, x and y are on opposite sides of the equation. So once again, we're not given a table. We have to create the table. So we have to essentially pick our points on our own, and we want to do that strategically. So looking at this equation, it's really easy for me to plug in values for x. If I plug values in for x, then I just have to multiply by 1/4 and add 3, and I have you know, a y coordinate that matches with that. So that's what I want to do. However, I need to be careful here, because if I plug in any old value for x here, I could wind up with a fraction, and fractions are not only hard to do arithmetic with sometimes, but you know, they're also very hard to graph. So if we take a look at this denominator of 4, right, that kind of gives me an idea of the types of x coordinates that I want to pick, right? As long as I pick x coordinates that are factors of 4, then when I multiply that number times 1/4, I'll end up getting a whole number, which will be really nice. So obviously I would want to start out with 4, right? So let's start there. If I plug in 1/4 times 4, then when I multiply these two, right, 1/4 times 4, which is 4 over 1, you know, I get 4 over 4, which equals 1. So I get 1 plus 3. So this whole thing turns into a whole number, which is really nice. So then I get y equals 4. So then 4 comma 4 is a ordered pair on the graph of our linear equation. Alright, so that worked out really nice. No fractions, numbers aren't too big. Alright, so let's pick another number. For x, that's a factor of, or a multiple, sorry, I should say, multiple of 4. Okay, so a multiple of 4 would be 8. 4 times 2 is 8. So let's try that. Okay, so if I plug in 8 into x and multiply here. All right, I get 1/4 times 8 over 1, so I get 8 over 4, and 8 divided by 4 is 2, so I get 2 plus 3, which is 5. So that worked out nice, right? This was a whole number, not a fraction, and that's what I wanted. Okay, so that gives me 8/5, and then I just continue that trend. All right, let's pick another multiple of 4. So we did 4 times 1, 4 times 2, 4 times 3, so 12. Let's try that. And if I look at my graph that I have here, 12 is going to be a little bit too big, right? Because 12 is not going to work on a 10 by 10 axis. So let's not go to 12. All right, let's regroup here. I can also use negative numbers. Okay, so let me take out this 12. So instead of using 12, right, let's use a negative number that's also a multiple of 4. So let's use -4. Okay, so -4. All right. So let's see what happens when I plug that in. Okay, so once again, because that's a multiple of 4, right, I'm not going to get a fraction, so -4 divided by 4 is going to be -1. So then -1 plus 3 gives me 2, so I get the point -4, 2. So we can use negative numbers for these coordinates. I try to avoid as many negatives as I can, but in this particular scenario, because I couldn't use 12 if I'm graphing it on a 10 by 10 XY coordinate plane, I had to go to a negative number. So, sometimes that is needed. All right, so let's graph that. So we had whoa, zoomed in a little too much there. Okay. So our equation was y equals 1/4 x plus 3. Okay. So the 3 points that we had was 4 and 4. So that goes here. 8, 5. And of course, the graph paper that I have printed here is not a 10 by 10, so I need to fix that. So I'm just going to add 2 more tick marks over here so I can get all the way to 8. So what did we say? 8 and 5. So 8 and 5 should be right in here. And then -4 and 2. So -4 and 2 would be here. And once again, our 3 points line up to form a line, and we get the graph of our equation. Okay. All right. So that gives you some examples to use that are similar to your homework. I wanted to give you a couple more examples here, and I'll be done. want to make sure that you're ready for any kind of problem that you see on the homework. So let's say that you have a equation that is x equals -3. And that's it. That's all you get. Okay, so there's no y. It's just x equals a constant. So x equals a number. Okay. Basically, this is a line in which every x-coordinate for the ordered pairs on the graph of this line is -3. So basically all the points look like -3 comma something, -3 comma something, -3 comma something. Okay. And what that does, it's going to create a vertical line. Okay, so anytime you get this type of equation where you have x equals a constant, that's going to be a vertical line. So, you know, basically these y-coordinates are going to be all of the points on that line. The x-coordinate's always going to stay at -3, and so, you know, the y-coordinates could be something like this: -3 comma 0, -3 comma 1, -3 comma 2. And so when we look at how that's going to be graphed, all right, here's -3 comma 0. Here's -3 comma 1. Here's -3 comma 2. All right, if this is going to be a vertical line that just goes up and down, every one of these points is going to be on this line. You know, as long as the x-coordinate remains -3, right, the y-coordinate can be basically anything, and that's going to still keep all of these ordered pairs straight up and down in a vertical line. And then so that gives us the graph of this linear equation. So the dead giveaway for these types of problems is if you see that x equals a constant. If you see that x equals just a number and there's no y in there in that equation, you should know automatically that's going to be a vertical line. Okay, something like that. All right. So the opposite of that, what if you get, you know, y equals a constant? So something like y equals 2. Well, this is going to be the line in which every y-coordinate is 2. So if every y-coordinate remains 2, what that's going to do is create not a vertical line, but a horizontal line. And pretty much these x-coordinates can be pretty much anything. So we'll just do 0, 1, 2 again. Okay, so let's see what these ordered pairs look like on a graph. So we've got y equals 2. Okay, so here's our point, 0, 2. Zoom in here so you guys can see a little better. 0, 2, 1, 2, 2, 2. And as you can see, you know, all of these points are going to be on that line. And it's just going to be a horizontal line. Every point on the line is going to have a y-coordinate of 2. So then when we connect those dots, that gives us the graph, which is going to be a horizontal line crossing the y-axis at 2. Okay. So that should help you with Module 5, Section 4, Graphing Linear Equations. If you have any further questions, please email or stop by the office. Have a great day.